In this course, we're going to be working with stiffness a lot, so let's get to know what this stiffness really is. So let's consider that if there is a spring right over there, and if I pull the spring in this direction with some force, then the spring is going to, let's say, elongate, right? So if we consider that force to be F and the elongation, so let's say it elongated this much, elongation to be delta, then we can write F is equal to K delta, and here K is the stiffness of the spring. Similarly, if we look at the Hooke's law, so if we look at the Hooke's law, this is sigma is equals to modulus of elasticity into string epsilon. Now let's come here and look at it. So this is what we get. This is Hooke's law. And here stress can be defined as force over area. Similarly, strain can be defined as the deflection divided by length, deflection or elongation divided by length. So if we replace those in this formula, for example, if I write out the formula right over here, which is equals to E epsilon. Now if I edit out this formula and we write P by A equals to E into delta by L. Now if we change sides and keep the force on the left side, we're gonna get EA by L into delta. So EA by L right over here, this EA by L can be written as K, because this EA by L is the stiffness. So we can write P is equals to K delta. So right over here we're denoting force with P, and previously here we denoted force with F. So P is force, so as well as F. So F and P both are force. Okay, moving on. So we have derived that P is equals to K delta, where K is the stiffness. So what is the stiffness? So if we rearrange this formula, we're going to get K is equal to P by delta. So you can say that the amount of force required for unit deflection is stress. So that is the definition of stress that is going to help us in this course. Okay, thank you very much for watching.